Hello guys and welcome to the GCSE Mathematics AQA Unit 1 Higher Tier Statistics and Number paper. This was the November 2015 paper and it's the same as the series for the June 2015 papers. We're allowed 1 hour for this paper and I'm going to take you through it step by step. So let's get started with question 1. A teacher recorded the number of lessons missed by 30 students. She compared the number of lessons they missed with their results in a test. And we can see a scatter diagram here. What type of correlation is shown? So for this, all we need to do is state the type of correlation, which is either positive or negative. If it's positive, then the gradient of the graph will be positive. However, this is a negative slope, so we're looking at a negative correlation. It goes downwards, okay? A negative gradient. And we can say, also we could add that it's a strong or negative correlation, but we can just leave it as negative correlation here, okay? So the next question says, 1b, draw a line of best fit on the graph. Well, line of best fit, all we do is pick a point here and try and draw a line through as many points as we can, approximately getting the same number of dots, or crosses in this case, on either side of the line. And this is a very accurate example, okay? So that would be approximately a line of best fit. And then 1c says another student missed 40 lessons. Use your line of best fit to estimate her test result. Well, 40 lessons missed is here. If we draw a line up to the graph, then a line across from there will be here, and so we draw a line up to the line we've drawn as a line of best fit, and then a line across from that to the y-axis, and we read off the value we get. If we do that, then we can see that here this is going up in 2s because it goes from 60 to 80 and the 10 small boxes, so it goes up in 2 each time. We have 66 there, okay? %, okay? And that is question 1. And what I would always do is get the mark scheme up so that you can easily check that you've got those questions correct. And this is the best way to go through exam papers. So we look at question 1a, negative correlation, so we're right there, straight line through there, and 1c, 66 exactly was a number that they said you could have, and the range is 62 to 70, so that's absolutely fine. So that would be question 1, okay? Okay, so there we go. Let's go back to this and move on to question 2a. An ordinary fair dice is rolled 420 times. How many times is the number 3 expected? So here all we need to notice is that on a dice there's 6 possibilities. The chance of getting any of those numbers on a dice is just 1 in 6. So the number 3 as well would be 1 out of 6. And that's the probability of getting a 3. And we're doing it 420 times. So we simply multiply 1/6 by 420. And we can use our calculator because this is a calculator exam. 1 divided by 6 times 420 gives us 70. Okay, so the answer is 70 times, and it's as simple as that, okay? Question 2b, a bias dice is rolled 50 times, the number 5 appears 23 times. Which of the following give the relative frequency of the number 5? So, in other words, what is the proportion 5 is coming up? Well, if 5 appears 23 times out of 50 times, then we have a fraction of 23 out of 50. So we're circling all of the correct answers, so there's more than one. Well, 23 out of 50 is the frequency of 5 appearing because it's thrown the number 5 appears 5 times out of 23. Out of 50 throws 23 times, so this is one answer. So what is that equivalent to? Well, as a decimal, 23 out of 50, if we type that into the calculator, is actually 0.46, so that's equivalent to this. And as a percentage, 0.46 when times by 100 is 46%. So they're the three answers we're looking for, okay? So this is just testing our ability to convert between fractions, decimals and percentages. 23 times the number 5 appears out of 50, so that's the fraction, and we convert between the three. So that's that, and again checking using the mark scheme, let's have a look. So we have 70 times, and the working out which we showed is there, and they're the three answers that we obtained, so that's correct. Now moving on to question 3. 40 students have brown, blue or green eyes. Half of the students with brown eyes are boys, and there are 6 more girls than boys altogether. And what percentage of the students have blue eyes is the question. Really what we're doing is filling out this table. So what we need to do is use the information we're told here. There's 6 more girls than there are boys, and there's 40 students in total. Well, if there are 6 more girls than boys and there's 40 students, then that must mean that there are 23 girls, okay? Because if there are 23 girls in total, then there are 17 boys in total. That makes a total of 40 students, and there are 6 more girls than boys, so this works. And now what we can do is go on to fill the table using this information, because half of the students with brown eyes are boys, and the total number of students with brown eyes here is shown to be 18. Well, if half of the students with brown eyes are boys, then half are girls. So 9 are boys and 9 are girls, because the total is 18. And now we can easily fill out the table, okay? Because we have a total of 17 here, we have 9 and 3, which when added together give us 12, and we have something else added to 12 to give us 17. Well, this must be 5. We can do the same with this column. 9 add 2 is 11. 11 plus something is 23. This must be 12. Now looking at the rows, 9 add 9 is 18. 3 add 12, well that's 15. 5 plus 2 is 7. And we can check this works. 18 plus 15 plus 7, using our calculator, well that indeed gives us 40, and so does this. So this works. And the question is, what percentage of the students have blue eyes? Well, if we look at blue eyes, the total is 15. So we have 15 out of 40 students. We can simplify that fraction down if we like, which is 3 out of 8. And then we can convert that to a percentage using our calculator. 3 out of 8, and we multiply that by 100, and we get 37.5%. So we just write that there. Let's make sure that's worked. Okay, 37.5%. So hopefully that's relatively straightforward. We're just using the information we're told to fill out as many boxes as we can, and then completing the table, linking back to the question to answer it, okay? And that's 4 marks, okay? So the next question. Ben wants to find out which type of music people prefer. He surveys 10 boys in a class. And we're asked to write down one way that Ben can improve his survey. Okay, so one way you can do this, and this is always an answer to this kind of question, one way is to increase the number in the sample. So a way of wording this, I'm going to write it here, is increase the sample size. So if we go down here to the mark scheme just to check question 3, because we didn't check that, 37.5 was correct, and for 3, that was right. 4, increasing sample size, okay? So that's what we said. Increase the sample size. Let's go back to that. That's always an answer, so it's worth learning this, okay? Question 5 now. There are 20 coloured balls in a bag. The probability of choosing a red ball at random is 1/4, and one more red ball is added. Write out the new probability of choosing a red ball. So we have 20 in a bag, okay? So the probability of choosing a red is a quarter. So in other words, there are 5 red balls initially. Okay, there's 5 initially because the chance of getting one is a quarter and is 20. So a quarter of 20 is just 5. One more is added. So now there is 6 out of 20. But it's 21 now because one more red ball is added. So that's one more ball to the total. So 20 add 1 is 21. And there are 5 red balls initially, and if one's added, that means 6 out of 21 are red. So the new probability is 6 out of 21, which we can simplify, because 6 out of 21 is just 2 out of 7. Okay. 2 out of 7. And that's question 5, so let's check that using the mark scheme. 2 out of 7. Yeah, 2 out of 7, okay. We could use that as a decimal, but it doesn't matter, we can leave it as fraction. That's absolutely fine. So let's go on to question 6, and this is a quality of written communication question, because it's got that star there, which means we're going to have to structure this in a way that makes it clear to the examiner exactly how we're answering this question. 2 boxes contain a mix of apples and oranges. In box A, the ratio of apples to oranges is 5 to 7, and in box B, 2 out of the 5 fruit are apples. A piece of fruit is chosen at random from each box. Is there a greater probability of choosing an apple from box A or B? Show your working. Now, as with the edXL paper which I've been through, this is very similar. The way you would set this out usually is with a table, just to make it very clear what's going on. And I would write out A and B, as in box A and box B, so that we can do it separately. If we just make this line shorter. So with box A, the ratio of apples to oranges is 5 to 7. So in other words, the total of the fraction is 5 plus 7, which is 12. So it's out of 12. And 5 are apples and 7 are oranges. So we have a probability of 5 out of 7 in box A. 5 out of 12 in box A. In box B, 2 out of 5 of the fruit are apples. So the probability in box B is simply 2 out of 5. Now we need to work out which of these is the greater probability. And all we do is convert these into a fraction that shows equivalence. So if we convert them to decimals using our calculator, well, 5 out of 12 is 0.42, rounded to 2 decimal places. And this is 0.4. So actually, box A has the greater probability of choosing an apple. Okay? So, and we'll write this here. Box A has a greater probability of choosing apples. And because this is quality of written communication, it's worth showing exactly how you've got to the fact that this is out of 12. So you could say 5 plus 7 equals 12. So 5 out of 12 are apples. And just indicate that 5 out of 12 are apples, okay, in box A. Okay, so let's go to the mark scheme on this one. And again, we get the marks here because we've shown that as a fraction they are greater. We've also shown in decimal form 0.4 and 0.2, so that gets us the mark. We can use any of these kind of methods. We could have converted them both to fractions of the same denominator. We could have used a ratio, but I used decimals. Either way you would get to the marks, as long as you're showing you're working. Okay, Right, let's move on to question 7. The page in a book has 31 sentences. The number of words in each sentence is recorded. Okay, so the table is given to us and we're told to calculate an estimate for the mean number of words per sentence. You must show your working. Okay, so what we do is we pick the midpoint, which is relatively straightforward, 3 to 5. The midpoint there is 4. Make sure that's going to show up. There we go. That's 4. 6 to 8, well the midpoint of 6 and 8 is 7. 9 and 13, the midpoint's 11. 16 and 22. To find the midpoint, you can, if you like, add together the two numbers and divide by 2, or you can just work it out in your head. It's absolutely fine. So they're the midpoints. And this is what we would label the total. And all we do here is we calculate the midpoint multiplied by the frequency for each row. So starting at the first row, 4 multiplied by 4 is 16. And it's worth noting that every type of question in this structure will always be the same for every exam, and these appear quite regularly. All we do is find the midpoint and multiply it by the frequency. So again, 7 multiplied by 13, we can use a calculator, is 91. 11 times 8 is 88. 16 times 5 is going to give us 80. 22. And then we add these together and we get 297. And all we do then is 297 divided by 31, and that gives us 9.58 to 3 significant figures. 3 significant figures, okay? Sorry, it's going to be 9.58, but let's just check how they've written this in the mark scheme. Yeah, 9.58 or 9.6, so that's absolutely fine. 9.58. Okay, so let's just go through that again, because I did go through that rather quickly. We calculate the midpoint. It's not always given to us in a table like this, so the midpoints are calculated here. We multiply the midpoint by the frequency. For each row, we calculate the total of each of these, and then divide by the total frequency, and that will give us our mean. And it's the same for every type of question in this format, okay? So moving on to question 8. The diagram shows information about the speeds of 100 cars. The fastest car has a speed of 70 miles an hour. How many cars were travelling above 40 miles per hour? Okay. So 40 miles per hour, all we do is go onto our x-axis, find 40, and draw a line up to the curve, and a line across, and read off the value here, which is 80, and we're asked how many cars are travelling above this, so we're looking at anything above 80, and the graph goes up to 100, so we do 100 minus the 80 to give us the amount above this, which is just 20, so 20 is our answer. Part B is another quality of written communication question. The slower speed was 5 miles an hour and the fastest speed was 20 miles per hour. Draw a box plot for the speeds of the 100 cars. So take note of what I'm doing here, because this is a question that comes up very commonly in exam papers, and box plots are drawn out in the same way each time. The slower speed is 5 miles an hour. So we find 5 on here, which is going to be there, and draw a line. It doesn't matter about the length of the line, the height of the line, as long as it's at 5 miles per hour. The fastest speed was at 70, so we go from the same point we have there. Okay, And now we need to find the upper quartile and the lower quartile. Okay, so upper quartile. Well, the upper quartile is 75% of the graph. The graph goes up to 100, so 75% of 100 is 75. So we get a line, draw a line from 75, which is there, across to the curve, and then we draw it down to the x-axis, which gives us 38, is that? Okay. So the upper quartile for the speed limits is 38. Okay. So we go to 38, which is there. We draw a line up, and that's our upper quartile. Now a lower quartile is the lower percentage, so if 75% is the upper quartile, then 25% is the first quarter. Well, 25% of 100 is 25. So again, we draw a line now at 25, which is there, across to the curve, and that gives us 30, doesn't it? That's 30, yeah. So the speed for the lower quartile is 30. And again, if you're doing this on your exam paper, you'll be able to get a clearer answer than I can using these tools, okay? So you want to draw a very accurate line across to the curve and read off the value exactly from the x-axis to make sure you're as precise as possible when calculating your values. So 30 is the lower quartile, which is there. And all we do now is we draw a line. Move that. Let's move that back. There we go. We draw a line from there to there, and a line from, keep moving that, there we go, from there to there. And now all that's left is actually to calculate the median. And the median is the 50th percentage quartile from the graph. And the 50th percent is simply at 50 because the graph goes up to 100, 50% of 100 is 50. And then reading off the value here. And the value looks to be 34, doesn't it? So 34 would be there. Let's get this right. Keep moving that. There we go. And that's 34. So that is what our box and whisker plot will look like for this example. Now with box and whisker plots, what we do is write the maximum, the minimum, and the upper quartile and lower quartile, and then do the mean. So this is the same for each type of question. And just to check, we'll go across to the mark scheme. Okay, so 8A should be 20, which is what we got, so that's correct. And 34 is the median, we got that. 30 and 38 upper and lower quartiles, 5 and 70 minimum and maximum. So that's absolutely correct, okay? So there we are. Okay, so let's now have a look at question 9. 3 positive whole numbers have a mean of 6. What is the greatest possible range of the 3 numbers? Well, the first thing to do is to realise that if we multiply 6 by 3, this will give us 18, which is the total of the 3 numbers that we're going to have. So the total of the 3 numbers summed together needs to be 18. And we're looking for 3 positive whole numbers with the greatest possible range. So straight away, the smallest possible whole number that we could have that is positive is 1. And if we're looking for the biggest range of 3 numbers, then let's pick 1 twice, because that way the next number we pick will give us the largest possible range. And we calculated here by doing 6 multiplied by 3 that 18 was in fact the number we needed in total. Well, 1 plus 1 is 2. 2 plus something is 18. The third number is going to have to be 18 minus 1 plus 1, 18 minus 2. So this number needs to be 16. And so this really is the greatest range that we can get, because we pick the smallest positive number we can have, and that's the largest number that will give us the range of values that give us a mean of 6. So the range here is just 16 minus 1. That's 15. We can check that using the mark scheme. So if we go up to this question, okay, yeah, so 1, 1 and 16 giving us a mean of 15, so that's correct, okay? So all we've done is multiply the mean by the number of numbers, which is 3 in this case, to give us 18, and then we've picked the smallest positive integer we have, which is 1. We've used that twice because that way we can get 16, which is the number that gives us the biggest range of values. So we've just got to think about this a little bit, okay? Question 10. The frequency polygon shows information about the heights of some women, and the table shows the heights of some men. 10a. Are the women or men taller on average? You must show your working. This is 1 mark, so here the modal class for the men is 170 centimetres. Let's make sure that's going to work. Okay, that's the modal class for men. And that's for men. If we look at for women, well, actually the modal value, the mode, is the highest value on the graph, which is this point here. And if we look, that point there corresponds to this point on the y-axis. And in terms of what this point corresponds to on the x-axis, we can draw a line down. I would do this in pencil in your exam, so that if you need to use a graph again, you can simply rub it out. But if we go down, we can see it's going to be this value here. It's 165 centimetres. So for women, 165. And 165, of course, is less than this range. It's less than the lower bound of this range. It's less than 170. So our answer is men. Okay? So all we've done is we've found out the mode from the graph, which is the highest point, and compared that with the modal class for the men, and clearly 165 is lower than the modal class for men, so men have a taller height on average. Okay. Now 10b says, are the heights of women or the men more consistent? Now with consistency, when we see this, instantly we should be thinking about range, because range shows consistency. And with men the range is 22. But what for women? Well, the greatest value for women is here, which corresponds to 195. So max value is 195. And that's for women. Min, so the minimum value on the graph is here. It's 155 centimetres if we draw a line down from here. And that's for women. And the range is just the maximum minus the minimum. So 195 minus 155. We type that in on our calculator just to make sure. And we get, yep, that's 40. centimetres range. So clearly the range for the women is greater than the range for the men. 40 is greater than 22. So in terms of consistency, the men are more consistent. Okay, that's not very neat, but there we go. The men are more consistent, okay, because the range for men is smaller. If we go to the mark scheme, because that's question 10 complete, we can see indeed that the men is the answer to the first one. Okay, there we go. And we just need to show that the modal class for women is 160 to 170. And it says except between 164 and 169, was that? Yeah, so as we said, 165 for women, so that will get us the mark. We can state the modal class, but it's absolutely fine to state the exact value. And for 10b, again, the range 40, which is what we got there. So for women, it's the minimum is 30. Again, there we go. Okay. So this shows we'd get both the marks. So there we are. Now looking at question 11, a price is decreased by 27%. The new price is £1,138.80. Work out the original price. So we have a 27% decrease. So what we're doing is we need to work out what have we multiplied our original value by to give us this new price. Well, if it's a 27% decrease, then 100%, which is the original price, minus 27%, well, that's going to give us 73%. As a decimal, we simply divide this by 100 to give us 0.73. So that's our multiplier. In other words, we've multiplied some value, x, by this number to give us £1,138.80. Well, if we've multiplied something by this to give us this, then if we divide this by this, it's going to get us back to our original value. So all we do now is divide the new price, which is this, by our multiplier, which was 0.73. And we have a calculator to do that on. And that gives us £1,560. Okay, and the pound sign's given to us. Again, it's worth checking that there is a pound sign there because we might have to include it if it wasn't given to us. So the answer is 1,560. So let's check the mark scheme there. Yeah, there we go. So that's the answer. There we are. So all we've done is found out the multiplier and then divided our new price by the multiplier to get back to our original value. Okay, and that's shown here, 0.73 divided by 0.73, so that's 3 marks. Question 12, 10 people move house. Here's a list of how far in kilometres their new house is from their old house. Which average would not be appropriate to use in this situation, and give a reason for your answer. So clearly you should be spotting that this value is way out from all the other values. This is what we call an anomaly in physics, and in any other science you will see this. So in other words, we don't want to be using this in our calculation because it's too high compared with the other values. It's going to give us an average which is not accurate. So the average we wouldn't use here is the mean. It's going to work. Is the mean. And the reason for this is one data point, or we could say value, is an anomalous result. This will give a false average that is higher than what it should be. So we'll see how they've worded it in the mark scheme, but this certainly will get us both the marks. We need to identify that the mean is what we wouldn't use, because remember, the mean is when we add together all of these values and then divide by how many there are. Well, there are 4, 5, 6, 7, 8, 9, 10 values here, and if we do all of these values added together divided by 10, then it's going to be much higher than it should be because of this anomalous result here. So we wouldn't use the mean because of that value. Going to the mark scheme. Yeah, mean, so that's 1 mark, 1 value not representative. So that's what we've said. Any indication that one of the values is not typical. So that's exactly what we've said. 1 data point is an anomalous result. This will give a false average that is higher than what it should be. So there we go. 13a. The probability of winning a game is 6.4 times 10 to the minus 3. What is the probability as a fraction? So simply converting this into a fraction. To do that, we need to write this in decimal form. What this is 3 jumps. 1 jump, 2 jump, 3 jumps, because it's to the minus 3. Okay. So this is the value in decimal form, and we can write that as that out of 1, which is the same thing, which is the same as 64 out of 10,000. Just multiplying the top and bottom by 10,000. And we can simplify this fraction down. If you have a calculator that can convert that, then that would be the best way to do it. And we could just type this into our calculator in this form, if you have a scientific calculator that allows you to do so. Convert to a fraction, or simplify this down, and we get 4 out of 625, which is the same as simply dividing the top and bottom of this fraction by 16, because 16 goes into both of them. Okay, so the answer is 4 out of 625. 13b. The probability of winning a different game is 1.5 times 10 to the minus 2. Work out the probability of winning this game both times. Give your answer in standard form. So the game's played twice, so if the probability of winning the game once is this, you can think back to probability tree diagrams. If we're doing the same thing twice, it's an AND question, so we're multiplying once and again. So we simply multiply this by 2. In other words, well, actually we multiply it by itself, don't we? We multiply it by itself so that we can get the probability when it's played twice. In other words, we square this value. And if we do that, we get 1.5 times 1.5, which is 2.25. And we need to remember our laws now when it comes to powers of 10 in this case. 10 to the minus 2 to the 2, all we do is we multiply the powers when it's outside of the bracket. Minus 2 times 2 is minus 4. So it becomes 10 to the minus 4. Okay, so we multiply the numbers in front, 1.5 by 1.5, and then 10 to the minus 2 by 2. Because it's squared, and that's using our law of indices. Okay, question 14. In fact, let's check the mark scheme on that one, just to be sure. There's our answer. Okay. So that's our method mark, and there's our answer, which we show. Question 14. A swimming club has 500 members. The club chairman wants to survey 60 members. Complete the table below for a stratified sample by age group and gender. Okay. So, all we do is we work out what each new value is going to be by doing the value in the table divided by the total multiplied by the number of members, so the sample size. So we do 45, first of all, divided by the total, 500, and we have to use this total here, the total of both the column and the row. And we can use our calculator, times by the sample size, which is 60, which gives us 5.4. And what we do is we have to round this because, again, we can't have 0.4 of a person. So this rounds down to 5. Okay, let's check that, yeah. And we do the same for each box, so next one's 33. Divided by 500 times by 60. And that gives us 35, 33 divided by 500, type that in wrong there, times 60, gives us 3.96. Again, we can't have 0.96 of a person, this rounds up to 4. So clearly you can see that's what we're doing here. We do the same for each box. So here we'd do 78 divided by 500 times 60, 130 divided by 500 times 60, 292 divided by 500 times 60. So I'm not going to show any more working in the exam. You should show every stage, but for the sake of this video I'm going to now go ahead and complete this table. So 130 divided by 500 times 60. It's 15.6, so that rounds up to 16. 292 divided by 500 times 60. It's 35. Okay, and as we can see here, that's exactly what we're doing. So that's going to be 51, 21 and 39. Just to show you with this last one, 33 divided by 500 times 60 is 3.96, which is what we got there. 78 divided by 500 times 60 gives us 9.36, which rounds down to 9. So again, that's that question complete. All we're doing here is each value in each cell divided by the overall total multiplied by the sample size, which is 60. So there we go. That's 3 marks, and that'll be the same for every question in an AQA exam that comes up like this. Okay, so just follow that method and show every stage of working. Question 15. The histogram shows information about the heights of 81 trees. The scale on the frequency density axis is missing. How many trees does the first bar represent? You must show your working. So, as with Edexcel papers, we need to apply a simple formula. So, let's move that over this way. Frequency equals frequency density times the width of the bar. The frequency density is on the y-axis always, and the width of the bar just means the distance on the x-axis. So to work out the frequency density, we simply rearrange this formula to get frequency divided by the width of the bar. So we have 81 trees, and that's the frequency that they've given us here. 81 is the total of all of these bars added together. So the way I would do this is using algebra. You don't have to use this method, but this is what I'm going to do. And I would always suggest using a similar method. So we know that the width of the bar here for this one is 1 to this value. And it's going up in 0.2s as you go along the x-axis. Because 1 is 5 bars, so each little box is 0.2. And we've got 2 little boxes across here, which is 0.4, and 2 bigger boxes, which is 2. So we have 2.4 as the width of the bar for this one. And we'll call this here one of these boxes with 5 smaller ones, so one of these size boxes, x, in which case this will be 2x, this will be 3x, 4x, 5x, and so on. And by doing this, we can actually work out an equation to solve. So 2.4, the width of the bar, times the height, which is 3x, times by 3x. So 2.4 times 3x, well 2.4 times 3 is 7.2. So here we have 7.2x. In other words, the frequency of this bar is 7.2 times x, x being some height on the frequency density axis. Now with this bar, we have a width of 0.6 and a height of 5x. Well, 0.6 times 5x gives us 5 times 0.6 is 3x. Now with this bar, just write that down there, 3x, we have a width of 1 and a height of 4x. So 1 times 4x is just 4x. And finally with this bar, we have 2 multiplied by x, which is just 2x. The width of the bar is 2. Multiplied by the height, which is x, 2x. So now we can form an equation, because we know that the total frequency given to us in the question is 81. So all of these added together, all of these areas of the bars which represent the frequencies added together, gives us 81. So 7.2x plus 3x plus 4x plus 2x will actually give us 81. And if we add all the x's together, using our calculator, 7.2 add 3 add 4 add 2, all of these added together is 16.2. If we just write that, 16.2 is therefore equal to 81, 16.2x that is. So we just divide through by 16.2. 81 divided by 16.2 is x, so x equals 5. In other words, each of these values on the frequency density axis is 5. So we can now get rid of, so this is why you do this bit in pencil, get rid of these and replace x, which is one big box, by 5. Now it doesn't matter really if we call x one of these really small boxes, it doesn't matter as long as we're consistent with how much we go up on the y-axis. We can form an equation to find out this scale, and now as we can see, how many trees does the first bar represent? This is the first bar, the width is 2.4 and the height is 15, so we just do 2.4 times 15 and that gives us 36. So the answer is 36, guys. And let's just check that using the mark scheme. 36, there we go. So there we go, they've done exactly the same thing as we have. We've labelled each one x and formed an equation to solve it. Okay. You may have learnt another method to do it, however I would recommend using algebra. I know this isn't very neat, but hopefully you've followed exactly what I've done there. And by forming an equation, it's easy to work out a scale, and then we can just apply that to the question. Now for part B, what fraction of the trees have heights greater than 4 metres? Well, greater than 4 metres, we're looking at anything to the right of this. Well, this bar represents 4x. We said x was 5, so this bar is 20. This bar is 2x, we said x is 5, so this bar is 10. So 20 plus 10 gives us 30. And this is 30 as a frequency out of a total of 81 given to us in the question. And using our calculator, all we do now is type that in and simplify it down. We can divide top and bottom by 3, and that gives us 10 out of 27. So let's check that. 10 out of 27, there we go. 30 shown, so that's a method mark. All we've had to do is identify that the total of the frequencies to the right of 4 metres, because it's greater than 4 metres it's asking for, is 4x add 2x, where x is 5, so that gives us 20 plus 10, which is 30, and then use that as a fraction of the total number of trees, which is 81. So that's 15b, okay? Okay, so now moving on to question 16. A baker has some bread mixture to make rolls. The mixture weighs 7,000 grams, and that's correct to the nearest 10 grams. Each roll uses 48 grams to the nearest gram. Work out the greatest number of rolls that the baker can be certain of making. You must show your working. So let's think about this. Here we have a bread mixture which makes rolls. So this is how much he has, and we need to find the amount that he can be certain of making. So this is in the worst case scenario. So if you think about this, the worst case is that in fact he has 10 grams less than 7,000 grams. It's going to be 5 grams less, isn't it? So if this is rounded to the nearest 10 grams, then he could actually have 6,995 grams. 5 grams less. Because if it's rounded to the nearest 10 grams, then this is the smallest value that would round up to that. So clearly, in the worst case scenario, he could actually find to have 6,995 grams of the mixture instead of 7,000 grams. And also in the worst case scenario, each roll could actually end up using 48.5 grams because this is rounded to the nearest gram. So the upper limit that this could be is 0.5 of a gram higher than 48. Because 48.5 would round down to 48, just as well as it could round up to 49. Now I know conventionally we round numbers up to the next value if we have something like 0.5. Usually we would round this to 49. However, for the case of this, we would use 48.5 because although it's conventional to round upwards, we could just as likely round down and it would be equally the same distance. For example, if we take the number 5, then 4.5 and 5.5 would be our two limits if it was rounded to the nearest whole number, because 5.5 could round upwards to 6, but the distance from 6 and 5 of 5.5 is exactly the same. So this is the worst case scenario, and all we need to do now is divide this number by 48.5. And this is the greatest number of rolls that the baker can be certain of making. in the worst case scenario. So 6995 on a calculator divided by 48.5 is 144.226 and some other numbers. And all we do now is round this to the nearest whole number. And if we round this, well, this is just going to be 144. Okay? So this is the greatest number of rolls that the baker can be certain of making. And let's check that on the mark scheme. Yeah, 144. Okay, so all we've done is use this word in the question where it says certain of making, which means that we've considered the worst case scenario, and the worst case scenario is that the baker has 6,995 grams of the mixture, and each roll could use 48.5 grams. So this is about rounding, okay? And finally, question 17. There are 7 white socks and 4 black socks in a drawer. 2 socks are taken out at random without replacement, and that's the key point there. Work out the probability that the 2 socks are the same colour. So this is a probability tree diagram we're going to have to draw. And 2 socks are taken. So we'll write up here 1 and 2, representing the first sock and the second sock. And then if we draw out the diagram, here would be our first branch. Just get rid of that. There we go. And this would be our second branch. There we go. So we have white and black socks, so we'll label that as follows. And in the first go, there's 7 white socks and 4 black socks, so in total there are 11 socks. On our second go, 2 socks are taken out without replacement. So after the first sock has been taken, there are 10 left. There we go. So there are 7 white socks, there are 4 black socks. And if we take a white sock in our first go, then there's only 6 left because there was 7 originally. So now there's 6, and again it's out of 10 now. If we take a white sock on our first go, then there's still out of 10, but there's going to be the same number of black socks, which is 4. If we happen to take a black sock on our first go, then there's going to still be 7 whites. And if we take a black sock on our first go, then there's going to be 3 left on our second go. So these are our new probabilities, and we're told to find out the probability that the 2 socks are the same colour. So we have 2 choices. We have white and white, or black and black. So if we consider the white socks, then the probabilities that we get white twice is just 7 out of 11 multiplied by 6 out of 10. Okay? And that's 21 out of 55 as a fraction. Now we could get 2 black socks, so that's 4 out of 11 times 3 out of 10, just multiplying along the branches, okay? 4 out of 11 times 3 out of 10. And on a calculator that gives us 6 out of 55. So the probability that the 2 socks are the same colour are these 2 values added together. 21 out of 55 plus 6 out of 55, which is 27 out of 55. And that won't simplify, so that is our answer. And we can check that again on the mark scheme. There we go, 27 out of 55. So there we are, guys, that's question 17. All we've done is draw out a probability tree diagram because 2 socks are taken, so we consider them as independent events, event 1 and event 2. And the key here is without replacement, so the fraction goes down by 1 on the denominator, and we have to consider the outcomes. And then if we're choosing the same colour, we could have these 2 branches or these 2 branches. And then we just multiply along and add our 2 results together to give us our total as a fraction. Okay, so that's the AQA paper from Unit 1 Higher Tier, which is from November 2015, which was allowed a calculator, and we had an hour to complete this paper. Hopefully time won't be an issue when you go through your exam. And the key point here is to go through the questions that you found particularly challenging and just make sure you completely understand the method behind them, because every year the questions that come up tend to be very similar. In fact, some of them even the same. So the key is to understand exactly how you should answer each type of question, and once you understand that, there's no reason you shouldn't be coming out with an A star in this exam. So this is Unit 1 for the higher tier. I will be going through 2 more videos on Unit 2 and 3 with the non-calculator and calculator. So there we go, guys. If you have any questions, please leave a comment, and if you found the video helpful, please do leave a like, and I'll see you in the next video.